Good morning to all. Today we are going to start with module 2. The title is Projection of Points and Lines. So all of you first write down title on a fresh page. Module 2, Projection of Points and Lines. The weightage of this topic is from 8 to 10 marks. It varies from 8 to 10 marks. So in topic number 1, that was orthographic projection, what you've done is you have projected an object on horizontal plane, vertical plane and profile planes. Now here, as the name indicates, projection of points and lines. So what you should be aware of, projection of points. So if you look at a point, how is an object developed, or let us learn how is an object produced or developed. So if you look at graphically, too many points. So if there are many points in a line, too many points form a line. So logically, point comes first. After that, line comes into the picture. And too many lines, for example, if you make too many lines, then a surface is formed. So first comes the point, second comes the line, next comes the surface, and too many surfaces forms an object. So the good thing is that we have already studied the projection of object. Now we need to study the projection of point, simply a point and a line. So from a difficult part, we are moving to a simpler part. So this topic is quite scoring. You may score full marks, but there are some important concepts you have to understand and remember before we develop. So once again, first comes the point, then comes the line, and next comes the surface. So all of you should know that point in engineering graphics can be called as a corner. Line can be called as an edge. So what is the definition of edge in engineering graphics? Edge means change of surface. So whenever two surfaces, look at surface A and B. So whenever two surfaces meet, an edge is formed. So the definition of edge is change of surface. So it is very clear that a line is made up of two endpoints. Suppose there are 2 points A and B, and if I want to draw a line, you can draw a line passing between them. So line is made up of two endpoints. So before we study projection of lines, we need to study projection of points. So let us move on step by step systematically and learn about points. Okay, so the next part is like this. Assume that the white paper is like a space as we've done before, and I need to divide this space into 4 parts. So the white part is the space. So as we have done in orthographic also, I need to divide this into 4 halves. So we will introduce a plane which is vertical. So say I am introducing a vertical plane over here. Okay, so you can see that this is our vertical plane. Okay, so I have introduced a vertical plane like this, what you can see. Okay, so let me slightly zoom in. Okay, so we'll call this as vertical plane and short form is VP. So now this concept what we're going to discuss today is very important, so please pay attention here. We know that the observer, so again this is the observer. Okay, so this is the observer. So the rule is that observer should always face, compulsory, observer should always face the vertical plane, that all of you know. So what you should learn from this diagram is, with respect to vertical plane, the space get divided into 2 halves, which is that number 1, this portion is called in front of vertical plane, in front of VP. VP means vertical plane. And the area which is on the other side is called as behind VP. So all of you know this. We can never say like this that an object is above VP or below VP. So with respect to vertical plane, it is never above or below. It is always in front and behind. So that is how the space gets divided into two half, correct? That is in front and behind. But we need four half. We need four half. So we will introduce one horizontal plane. Okay, we will introduce one horizontal plane. So let us do that. Okay, so here I'll be introducing a horizontal plane. So the behind part may not be somewhat visible. So I'll show some portion hidden. Okay. So that is how I have introduced one more plane which surface is horizontal. So we'll call this as HP. So VP and HP are the two principal planes. Principal means main, important planes. So one more thing we are aware of, wherever this VP and HP intersects, if you look at the VP and HP plane, they intersect somewhere along this line. So this line is a medium dark line because it is imaginary. Actually the whole plane is imaginary. So this medium dark line is called as XY line. Okay, so XY line is over here. So as I told you, with respect to vertical plane and from the observer's point of view, we can say this is in front of VP and this is behind VP. Similarly, with respect to the horizontal plane, what we can say is this portion or this area on this side. So there are two partitions because of HP. See, these are the two partitions shown by blue color. So this portion is called as above HP and this portion is called as below HP. Okay, so that is how the space is being divided into four half. The space is being divided into four half. So moving forward, we also know that along with this four half, there are four quadrants. So observer's position is fixed, you cannot change. So we know that this portion from here to here is called as first quadrant, that is clear, Roman 1. This portion over here is called as second quadrant. This one below on this side is third quadrant, and the last this one is called as fourth quadrant. Okay, so all of you are aware about these basic things. So very important thing for projection of line is what? With respect to VP, it is in front and behind. With respect to HP, it is above HP and below HP. Okay, so this thing is clear. Okay, we know that whenever you place an object in the first quadrant, suppose if you place any object, let the object be in the form of a point. So if you place an object in the first quadrant, what you should say is this object is above HP and in front of VP. If an object is placed in the second quadrant, suppose an object is placed in the second quadrant. So my question to all of you is, when you look in the front view, can you see this object in the second quadrant? So answer is no, because there is an interruption. Vertical plane is in between. So whenever an object is placed in the second quadrant, you need to make an assumption. The assumption is that vertical plane is transparent. Correct? Because it is transparent, only then you can see this object from here. So remember, you can't say that, sir, I will go behind and see the object, because observer's position is fixed. So if you want to see the object from here, which is in the second quadrant, the assumption is the vertical plane is transparent. So in the second quadrant, if an object is placed in the second quadrant in the form of a point, how will you define this point or define this object with respect to HP and VP? You should say this object is above HP and behind VP. Similarly, if an object is placed in the third quadrant, so you need to sit down. It means the observer should come somewhere here, right? See here. The observer should come here and look from this side. So again, you cannot see this object in the front. So VP is again assumed to be transparent. One more thing is, when you look in the top view from here, you cannot see the object in the third quadrant from top view also. So whenever an object is placed in the third quadrant, both HP and VP are assumed to be transparent. Okay, So in the second quadrant, only VP was transparent because from the top view you can directly see the object. But in the third quadrant, both VP and HP are assumed to be transparent so that you can see the object clearly. So how will you define an object which is placed in the third quadrant in the form of a point? You can say this object is placed behind the vertical plane and it is below HP. Okay, behind VP and below HP. Last but not the least, if an object is placed in the fourth quadrant, then which plane is assumed to be transparent? So when you look in the front view, you can directly see the object. But when you look in the top view, HP is the interference. So in the fourth quadrant, only HP is assumed to be transparent. Correct? So how will you define a point in the fourth quadrant? So you should say this point is below HP. Where it is? Below HP and in front of VP. Below HP and in front of VP. So this is how an object is defined with respect to HP and VP for all the four quadrants. So one more thing what all of you should be aware of, the method of operating the plane. So whenever you find VP and HP and if it is being asked how are you going to operate the plane, what you should say is this vertical plane you need to hold constant by one hand, and this HP what you can see which is a single piece of glass, you need to turn in this direction. So we need to turn like this, isn't it? So always it is compulsory when looking from this side, you need to turn in clockwise direction. So because this is one single piece of glass, the opposite part has to move up. So this end will move up because it is like a seesaw. So when one part has to go down, the other has to move up. So this is the one and only one method of operating the plane. VP is constant and HP has to be turned down. Okay. Also you should be able to visualize this diagram from the side. So all of you look from the side. So in the side, HP is seen as a horizontal line. So let me draw horizontal line here. So this is HP. And VP seen as a vertical line. So this vertical line is VP. If you look at X and Y in the side view, it is seen as a single point. So this single point is XY. I hope all of you are able to visualize. Where is the observer now? Yes, so observer is looking from this side. So this is observer X. X means observer. So what is the method of operating the plane? Always turn HP down in clockwise. So the opposite part has to move up. Okay, it's like a seesaw. Apart from that, this is our first quadrant, this is the second quadrant, this is the third quadrant, this is the fourth quadrant. And see, observer is on this side once again. So remember that this portion is called in front of VP and this is called behind VP. So with respect to observer, in front and behind, and with respect to observer, this is above HP and below HP. So all these terms you have to learn in projection of points and lines. Let us now start understanding projection of point in first quadrant. So all of you have to be very attentive to understand this part. Okay, so let us see what is that. If I assume a point capital A in the first quadrant, suppose the name of the point is capital A, which is in the first quadrant. So we know that this is VP and this is HP. And HP has to be turned always in the clockwise sense like this. So once again, how will you define A in the first quadrant? It is said to be above HP and in front of VP. Now carefully look here. Suppose if I say point A is 40 millimeter above HP. If I say point A is 40 millimeter above HP. So what I want you to visualize is, all of you are requested to look in the front and look at this object. So here the object is a point. So what will happen is, we know that the front view of any object is projected on the vertical plane. So when I do that, and if I project this on the vertical plane, the actual image you're going to get somewhere here. So this is the image of the object capital A, which is projected on the vertical plane. So if capital A is 40 above HP, and if you look in the front view, it means that this vertical plane or this blue point, that is also 40 above xy. So try to visualize this, all of you. So once again, if a point is 40 above HP, it clearly means that the front view of the point is 40 above xy because they are parallel. So see, both dimensions are 40, right? So we need to give some name to this point. So now onwards, what you should remember, the actual object is represented by capital alphabet, but its projection is represented by small alphabet. So A is the actual object and capital A is the actual object and small a is the projection. But whenever you find a small alphabet with a dash, so you have to understand that it is the front view of the object. So the conclusion is like this: if an object is 40 above HP, it means its projection A dash will be 40 from xy. Okay. So now all of you look in the top view from here. Look at the top view of A. Suppose if point capital A is 50 millimeter in front of VP. So look at the point top view of the point A. The top view of point A, the projection of top view of point A falls on horizontal plane as we know. And this will be denoted by small alphabet A without dash. So you need to by heart right now that anything without dash is the top view of the object and anything with dash is the front view of the object. So once again, if you carefully look here, this point capital A is 50 in front of VP. That clearly means that the top view of point small a is 50 in front of xy. So straight away we can write down that this dimension is 50. This dimension is 50. Okay, so hope the concept is clear. So 40 above HP means 40 above xy. 50 in front of VP means 50 in front of xy. Okay, now for time being, forget about the actual object and you visualize that you're left with the image alone. So forget about the object and you're left with the image alone. So you're left with only A dash and A. Okay, now in orthographic we have learned that always the object line should be shown dark. So the name of the topic is projection of points. So here the object is the point. So only A dash, the small circle, and A has to be shown dark. Then what is this green line called? So the name of the green line, what you have to by heart is projector. It is the projector of object capital A. So we know that in orthographic, whenever we draw front view, we knew that front view and top view एक ही line में आते हैं. So all of you have done that, right? So if you draw a rectangle in the front view and if you project that, you'll get top view below that exactly. So we need to understand that each and every point of the front view and corresponding top view has to lie one below the other. Same way here, A dash and A has to lie on the same line. So the green line what is being drawn is called projector of A. Now all of you will turn HP down because we need to operate the plane and see what is the consequences. So when you turn HP down, so HP will be somewhat like this, right? So HP will occupy like this here. And what will go down along with it? Any idea? Yes, point A will go down. So this green line will come down and this A will swivel. A will turn and will occupy the position below XY, isn't it? So A will come here. So the moment you turn HP down, this 50 millimeter becomes vertical and A dash and A will lie on the same line. So if you look at the new diagram from the front, how we can draw, I'll tell you. Okay, so let me adjust a little. Okay. Yes, so if you look at the new diagram from the front, you will get an XY line over here. So this is the XY line, which is medium dark. The green line is called as the projector of A, which is light. So this line has to be light. Okay. Now, if you look at this diagram, A dash, that is the front view, is 40 above. Okay, so from XY, you need to move up by 40 and mark a point here. So this point is A dash. Now where to write A dash, all of you observe this. A dash should be written on the left side and above. I will tell you why above. So it should be written where? left side and above, compulsory. Now where is A? A is 50 below xy. So from here, if you look at the diagram, point A should lie on the same projector. So the green line is called projector of A. Point A should lie on the same projector. And where you should write A? You should write on the left side and below. Mirror image of, so this is the mirror. A dash is written above, so A has to be written below. Why it is so? Because if you write A dash and A here, then what will happen is while showing dimension, so you know that dimension is shown by first drawing extension line. So if you write A dash somewhere in the middle, it will get cancelled because of the extension line. So A dash and A should be written on either side of the extension line, and then you should leave some gap, and you have to show dimension the standard way, means the arrow mark should be 3:1 medium dark, right 40 above the line and along the line. So that is how only the object has to be dark, that is the point should be dark, the light line should remain as it is. Okay, so in first quadrant what happens is that front view is always drawn above xy, that is what we are doing till now, and top view is drawn below. So you need to by heart that in first quadrant, so this is the first quadrant, front view is always above and top view has to be drawn below. So this part is clear. Now let us move on to the second quadrant. So we have seen the first quadrant. Now we will see about the second quadrant. So I write down second quadrant over here. So we have to see all the four quadrants, how to project a point in four quadrants. So now in the second quadrant, if I place a point capital B in the second quadrant, that is somewhere here. So we know that if a point is kept in the second quadrant, it is called as the point is above HP and behind VP. Above HP and behind VP. Suppose this point is say 30 millimeter above HP, and if the same point is 60 behind. So we know that observer is looking from this side, correct? And VP is assumed to be transparent. So now carefully look in the front view from here. Because VP is transparent, you can see the point B from here itself. So in the front view, you'll get the projection on VP, and this is called as small b with a dash. Similarly, if you look in the top view, तो top view यही से देखना है, you should look from this side. So top view of point B will fall here, called as small b without dash. So B dash and B are the front view and top view respectively. Now, because point B is 30 above, it means when you look in the front view, this B dash has to be 30 above xy. So even this is 30 because they are parallel. And because this is 60 behind, it means top view B is 60 from here. So it is 60 from here. Okay. So now what is going to happen when I turn the HP down? So when I turn HP down, the opposite part has to go up. So see, when you turn this down, B dash which is on VP will remain here only. That is 30 above xy. But B which was behind VP will now move up. Because when you turn this part down, the opposite part has to go up. So this B which is on HP will move above xy, and that is by 60 mm. So in second quadrant what happens? Both front view and top view of an object lies above xy. So we have not drawn orthographic chapter number 1 in second quadrant, because in second quadrant what happens? The front view and top view overlaps. So if I ask you, suppose draw front view and top view of an object in second quadrant, then what a student will do, first he or she will draw the front view, okay, and then you have to draw top view within that only. So both the views overlap and you won't understand anything. First of all, first quadrant भी थोड़ा कम समझ में आ रहा है. The views are separated, then also you can't understand thoroughly. And if I ask you to draw in the second quadrant where first and second overlap, then you won't be able to understand anything. So you need to remember that in second quadrant both the views overlap, and that is why orthographic is not drawn in second quadrant. So that concept should be very, very clear. So when I open the plane, or when you turn HP down, this part will go up. So VP and HP will overlap and both will be above xy. So let us try to draw that part. So here if I try to draw this, so this is the xy line. I'll write x and y. After that I will draw a light projector. Okay, so have you noticed one thing? That after you turn HP down, this has to go up. So the projector of B and B dash will fall on the same level. And which point will be more above? So B will be more above. So here what will happen is I will mark a point and write above as B dash, and B is further far more away. So this dimension from here to here, as we are showing, this is 30 millimeter and this is 60. So in the second quadrant, what you have to remember, so dash means front view of course, without dash means top view. So in second quadrant you have to by heart or remember that front view and top view both are above xy. In second quadrant both front view and top view are above xy, that you have to remember or by heart. Okay, so there is no doubt till now. Now tell me, suppose this is 60 and if this was also 60, then what will have happened? If both are 60, then so when you turn HP down, this will go up. So B and B dash will coincide and will form a single point called as B dash. Okay, so this part is clear. Now we will switch on to third quadrant. So I'll write the title over here as third quadrant. Okay, so third quadrant I've written here. So in the third quadrant, we know that this portion is third quadrant. So if I define a point capital C in the third quadrant, what we will say is this point lies below HP and behind VP, and observe is looking from here. So both the planes VP and HP are assumed to be transparent. So when you look from this side, you cannot see the object. So VP is transparent, and when you look from top view, you cannot see the object still. So HP is also transparent. Okay, now if you look in the front view from here, the projection of C falls here. And when you look in the top view, the projection of C falls here, isn't it? So I hope all of you are able to understand this. So in the front view, when you look here, the projection of C is called as C dash. And in the top view, the projection of C is only C without dash. And one important thing is, the projector of C and C dash will fall on the same level. Okay, because top view and front view are always on the same level. Now all of you turn HP down. So the opposite part has to go up, isn't it? So what will happen is the top view of the point C will now fall above xy and the front view will be below xy. So in third quadrant, front view lies below and top view lies above, and this is called as the projector of C, which will be drawn light. So let us try to draw this diagram accordingly. So here I will draw a medium dark xy line. I will draw a light projector. Now as per the diagram, the top view C, when you turn HP down, this will go up. So this top view C has to move above. So I'll mark a point and always write C on the left and above. And C dash will remain down, isn't it? So below xy, C dash will remain here. So where to write C dash? Left side and below. And this light line is called as projector of C. So only the object, that is the point, has to be dark. So top view is here and front view is on this side. So we can say that when you compare this with the first quadrant, what we can say that first and third are exactly opposite. In first quadrant, top view is below xy. So in third quadrant, top view is above. In first quadrant, front view is above xy. So in third quadrant, front view is below xy, because they are exactly opposite. Okay, and the reason is the mode of operating the plane downward, so this has to go up. Okay, so I'll write down that this is a third quadrant. So first and third are exactly opposite, so here the views do not overlap. So orthography can also be drawn in third quadrant also, but in our syllabus it is being restricted to first quadrant only. Otherwise drawings can also be prepared in third quadrant, where top view is above xy and front view is below. Coming to the last part, let us now understand fourth quadrant. So this is the fourth quadrant. So how will you define a point in a fourth quadrant? So whenever a point lies in the fourth quadrant, let the point be capital D. You can call that this point is below HP, where it is below HP and in front of VP. Below and in front. So when you look in the front view, the projection of D falls here. And when you look in the top view, you cannot see the point. So this HP is assumed to be transparent. So the projection falls here. So in the front view, let the projection over here be D dash. The front view is always dash, so it is D dash. And the top view, this point is D, isn't it? So top view falls on HP and front view falls on VP. And you can very well see that this line and this line fall on the same vertical, same level. This is called as the projector of D. So now let us turn HP down. What is going to happen? When you turn HP down, the top view of the point D will also go down. So front view and top view of the point both will be below XY. Correct? So here when I draw this one, so this is that XY line. So in other words, we can say that second and fourth quadrant are exactly opposite. So here what happens when you draw the projector, okay, like this. So here the points lie below. Okay, now suppose, assume that the distance are same. D and D dash are at same distance 20 each. So when you turn, D and D dash will overlap. So in this diagram, how to write D and D dash? Right below and on the left side, like this. So this is the fourth quadrant where front view and top view both are below. Okay, so this is the fourth quadrant. Okay, so now it's time to conclude. You need to by heart that in first quadrant, front view is always above XY and top view is below XY. In second quadrant, this is the second quadrant. In second quadrant, front view and top view both are above XY. Here the views overlap. So orthographic is not drawn in second quadrant. In the third quadrant, which is exactly opposite of first, here top view is drawn above XY and front view is drawn below XY. So orthographic can be drawn either in first quadrant or in third quadrant. But if you look at the finally fourth quadrant, it is exactly opposite of second, where front view and top view lies below XY. And orthographic is not drawn here also because the views overlap. So finally first and third quadrant is the proper quadrant to show orthographic, where the views are separated out. So why the views are falling up and down? It is because of these technical reasons, what you can see here, all these four. So this is the basic concept what is required for points. Okay, now all of you on the page where you written projection of lines as the title of the topic. Now let us start working. What you have to do is that you approximately, no need to measure, approximately this is the height of the page. So if I mark half of the height, okay, I'll mark half of the height and draw a medium dark line. So let me align the scale. So we need to practice projection of points first before we learn lines. But in exam questions will be asked only on projection of lines. So points is used to develop lines. So if a student doesn't know how to project a point, that student cannot learn lines also. So you are supposed to draw a medium dark XY line, okay, and you have to write capital X and capital Y. So let's see. So draw a medium dark line approximately in the center of the page and write capital X. Where you should write capital X? Midway of the line, half X up and half X down. Here half Y up and half Y down. So all of you write capital X and capital Y on both the sides. Next what you have to do is that on this medium dark line, I need to draw some projectors so that I can practice projection of points. Let me mark 8 projectors because I'm going to practice 8 such points. So I will leave a gap of from X, I will mark 20, 20, then 40, 60, 80. So I need to mark 8 such points, 1, 2, 3, 4, 5, 6, 7 and 8. Okay, then I will just shorten this Y. I don't need this Y till here. So I'll just shorten this Y and write Y on this side. So you need to mark 8 points. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and I need to draw 8 light projectors because projectors are always light. Okay, so to draw 8 light projectors, so suppose this is your roller scale. So the height of the projector should be approximately half the roller scale up and half the roller scale down. So here I need to draw a light line, say 40 up 40 down or 50 up 50 down. So it should be very light. Projectors are very light. Now draw lines parallel to this projector. Okay, so once it is ready, we can draw parallel lines by roller scale. So just quickly you need to draw this fast. You need to hurry up. So draw light 8 such light projectors. So say approximately half up and half down. So here if I want to name, what you should do is that this first light vertical line is the projector of capital A. So let us write capital A here. Then you have capital B. Over here capital C, capital D, E, F, G and H. So all these are the projectors of the actual object. So once again revision, capital alphabet means it is the actual object, and small alphabet in terms of dash and without dash is the front view and top view respectively. Okay, so need not all the projectors need not be in the same level. You can draw in same level also, half up half down approximately roughly. Yeah, so all of you quickly draw 8 light projectors A, B, C, D, E, F, G, H. The gap between the two projectors is 20 millimeter each. From X also you can leave 20 and from Y also you can leave 20. And the projectors are light. Approximately you can say 50 millimeter up and 50 millimeter down, or 60 up and 60 down. That is the way you draw 8 light projectors. So let us start with the first question. First question is point A, 40 mm above HP and 10 millimeter in front of VP. What you're supposed to do is that, having read the question, you're supposed to plot the front view and top view of point A with respect to XY. So let me show you an example. So point A is 40 above and in front. So if you combine above HP and in front of VP, you'll come to know that the object is in first quadrant. So if you draw first quadrant like this is the first quadrant, right? You're not supposed to draw all these quadrants. Just you need to understand the first question. So point A is 40 above. Let me mark A here. So when you look in the front view, this point will give you A dash, and when you look in the top view, this point will give you A. Now read the question thoroughly. Point A is 40 above. So if a point is above HP, it means A dash is above XY. So this dimension is 40. If a point is in front of VP, suppose this point capital A is in front. So from where will you come to know in front? If you want to look at in front, should you look from the front or should you look from the top? Yes, from the top view you can come to know how much it is in front. From front view you cannot come to know how much an object is in front, but you can come to know how much it is above. So if an object is 10 millimeter in front, it means parallel to this, even this is 10. So now carefully look at this projector and turn HP down. What is going to happen? A dash will remain up by 40 and A will go down by 10. So that is clear. You have to mark A dash 40 above X5 and A will be 10. So see, in the question they are given with respect to HP and VP. The question is given with respect to HP and VP, but you have to answer in terms of X5, how much it is above X5 and how much it is below. It cannot be in front of X5. It has to be below after you turn HP down. So after I turn HP down, this line will go below. So question is with respect to HP and VP, but answer should be with respect to above and below XY. So I need to mark A dash 40 and A 10. So let us see the answer now. So what you do in your book is, this is the first answer of A. So keep your scale here. At 40 from here, you mark a point and show it dark. And then come down by 10 and show one point dark here. So you have to mark 2 points. One is 40 above and 10. After that, what you should do, first observe and then you have to draw. Align the roller scale with XY. Leave gap of 2 millimeter and then draw medium dark extension line. And here also leave gap of 2 millimeter and then draw medium dark extension. Before that, above the extension line, name this as neatly as A dash and this as small a, where you should name left side above, left side below. Then leave a safe gap of 8 to 10 mm and you have to show dimension over here as 40 and 10. So arrow mark should be same what you have done or studied before, 3:1 ratio arrow mark. And above the line and along the line you should write 40 like this, and 10 should be written here. So that is how only and only the point should be dark, because this is the actual object. Now the second question is over here. Point B is 20 millimeter above HP. Try to visualize above and 20 behind. So in which quadrant the point lies? Above and behind. It is in the second quadrant. So when you draw the second quadrant alone, so let us forget about other quadrants. We will draw only the second quadrant, and observer is looking from here. So this is VP and this is HP. So point lies 20 above and 20 behind. So let this point be capital B. So when you look in the front view, the projection of B falls here, called as B dash. And in the top view, the projection lies here, called as only B without dash. Now this point is, once again read the question, 20 millimeter above. So if a point is above, it means parallel to this, even this is above. So this is 20. And 20 behind. Again, you cannot see a point how much it is behind from the front. You cannot see a point how much it is behind from the front. So you need to go in the top and find out how much it is behind. Okay. So behind can be seen only from the top view. Okay. So they are saying this point capital B is 20 behind VP. So parallel to this, even this is 20. Now in which direction should I turn the plane? All of you look from here. Should I turn the plane anti-clockwise or clockwise? So the answer is always clockwise. So by doing that, what will happen? B and B dash will overlap and give you one single point B dash. So this is the second quadrant part. So let us plot that answer in our diagram over here. So besides this, you can see projector B. So move up by 20. Mark a point, and left side and above write B dash. No need to put comma in between. Just write, as you can see on the screen, B dash. And dimensions are very important. Without dimension, drawing has no meaning. So from here you need to show 20. To show 20 millimeter from here. Correct? Yeah, next you have this one. Point C. It is 25 millimeter below HP and 40 millimeter behind VP. So anything which is below and behind lies in the third quadrant. So let me draw only the third quadrant, so make you understand. So third quadrant is over here. So this is the third quadrant. Observe looking from this side, and point C is below HP. So it is below HP. This is our HP and behind VP. So if you look in the front view, the projection of C falls here, called as C dash. The front view is always dash. And when you look in the top view from this side, the projection of C falls here. So let me shorten a little. Yeah, so suppose actual C is over here. So when you look in the top view from here, projection of C falls here, called as C without dash. Okay. So now they are saying point C is 25 below HP. So from HP, if you look at this C, it is 25 below. That is what they are saying. So if this is 25, automatically this will also be 25. So here is 25 below. Now it is 40 behind. So behind can be made, can be understood only from the top view. So from VP, this dimension is 40 behind, isn't it? So this is called 40 behind. So when you look in the top view, even this has to be 40. See, because both are parallel. Here this both are parallel, so this is also 25. So now again, when you want to turn the plane, always turn the plane in clockwise direction. What is going to happen? C dash will remain down by 25 and this C will move up. Up means above XY by 40 millimeter. So in third quadrant, front view always remains below XY and top view is above XY. So we need to mark 40 above and 25 below. So let us do that here. 40 above and 25 below. 10, 20, 25. So I'll mark these 2 points. And they are shown third quadrant. So this will be C and this will be C dash. For dimension, once again, align your roller scale with XY line, move up, draw extension line medium dark, move down, draw extension line medium dark. Then from here, vertical line. And here we need to show arrowheads. So this dimension was 40 and the another dimension was 25. Okay, now the next question is like this. Point D on HP and 20 millimeter in front of VP. So can you guess which quadrant does it lie? Point D is on HP. So this is your VP. This is your HP. So point D lies on HP. So this is your HP. This is your VP. So point D is neither above HP nor below HP. It is on HP. And 20 millimeter in front. In front means this is called in front, right? So when you mark point D, it is neither above nor below. So half point is above. You can say it lies exactly on HP, neither above nor below. This is your point D. And how much it is in front of VP? So from here, this dimension from here to here is 20 millimeter in front. So we can say that this point is partially above HP and partially below HP, or exactly it is on HP. So it belongs to first quadrant and fourth quadrant both. So the correct way to define this point is this point lies in both first and fourth, because point D is partially up and down. Now try to visualize this point from the front. So from the front view, the projection of D falls here, called as D dash. Front view is always dash. And when you look in the top view from this side, the same point is D without dash. So in the front view, projection of capital D is D dash and top view is D. Now rotate HP in clockwise sense. So what is going to happen is D dash will remain on XY and D will go down by 20. So let us plot this here. So here when I plot this, so I'll mark D dash on XY. So let us mark D dash on XY. So D dash will be written here. Okay. So D dash is on XY and D will go down by 20. So we'll mark 20 on this side. So D dash you have to mark on XY as per the solution. And when you turn the plane down, D will move down by 20. So from XY line, we need to move down by 20 and mark a point D and right below and on the left side. So this dimension parallel to XY we need to show here. And write 20 on this side. Now the next part is point E on VP. Point E on VP, neither in front nor behind, and 35 above HP. So in which quadrant the point lies? On VP and 35 above. So it lies in first and second both. So let us mark this point. So point is on VP. So see, whenever a point lies on VP, there are two possibilities. It may lie here or it may lie down. But they have mentioned further and above HP. So it is clear that that point should be here. So this is that point capital E which is on VP, and 35 above means from here to here. This vertical dimension is 35. So now carefully look in the front view. In front view when you observe, the same point is small e with a dash, because front view is always dash. But when you look in the top view, because observe is here, when you look in the top view, the projection of E falls on XY, called as small e without dash. So when you turn this HP down, E dash will remain there itself 35 above and E will remain on XY. So the positions are not going to change. So let us mark E dash and E. E dash is 35 above. So we will mark E dash 35 above. So I will mark 35 from here. And E will remain on XY. So E will remain here and E dash is above. So let us show dimension from this side. So this is 35. So the next part is point F on HP and 40 behind VP. Point F on HP and 40 behind VP. So when a point is on HP and behind, it means the chances are the point can be in second quadrant or in the third quadrant. So let us mark a point F on HP. So whenever a point lies on HP, neither above nor below, it means the point can lie here or it can lie on this side, right? On HP. But if you read the question further, it is behind VP. So on HP and behind VP means the point lies here itself. So this is that point capital F. And it is 40 behind VP. So from here, this dimension is 40. So when you look in the front view from this side, so observe is always on this side. So when you look in the front view from here, this green point what I marked is F dash. Front view is always dash. But when you look in the top view, the same point will be F, isn't it? Without dash. So top view will lie here itself and front view will be on XY. So when you turn HP down, this has to go clockwise. So this will also go clockwise above. So F dash will remain on XY, correct? And F will move up by 40. So F dash will remain on XY and F will move up by 40. So let us mark F dash on XY right below on the left side. And F will move up by 40. So 40 above, let me mark a point. And write F on this side. After that, just show the dimension here. And write 40 like this. Okay. The next part is very, very difficult. The most difficult of all. Point G on both HP and VP. How it is possible that a point lies on both HP and VP? So it means, correct, it means point G lies on all the four quadrants and that is on XY. If a point has to lie on all the four quadrants, it means it should lie on XY because point G has to satisfy the requirements of first, second, third and fourth quadrants. So when you look in the front view, this point is G dash. In the top view, the same point is G. And when you turn the HP down, there won't be any effect. So very difficult. So here, this point is G and G dash both. No need to show any dimension because there is no dimension at all.